Hi dragons! How you doing, my research dragons? So couldn't make it in today because of the black ice, which someone came left of center and almost hit me head on. So that was enough. But anyway, so we're going to continue with research methods on video, and then on Tuesday there will be a guest speaker, and there will be one on Friday. So please come to class, and please make sure you're there on time. I will also put in something for the forum today so that you can, so I can get attendance record for your scholarships and financial aid and all that other stuff too. So make sure you do that. And watch the videos, which hopefully you're seeing this and you're watching videos. Okay. So, I think we left off at, let me see now. We left off at comparative research. I was talking about how that used to be between animals and humans, but now people have used comparative research, or use the term comparative research, and they're talking about different cultures or different locations, like if you're comparing United States to another country or something like that. So you will see them in both, comparing humans to animals and comparing, different countries. So another type of research that you, might do is a pre-test, post-test, okay? So let me tell you about a study that I always really wanted to do. And it was because one of my grad students, made a comment that was really funny, and I was like, it set me thinking, like, oh, I wonder what that's like. So this one student that I had, she's a very funny gal, and she said, I love the grad program. It was so good. I learned a lot. She's going on and on about the grad program. And then she said, but I'll tell you, I came into the grad program excited, happy to learn, really at ease and everything. And she says, and now I'm ready to graduate and I'm partying like a rock star. And I picked up some habits with my classmates, going out for drinks and things like that weren't the healthiest. And she said, because we were so anxious all the time in grad school to like succeed and all this other stuff. So I thought, wow, wouldn't that be a great study if you took an incoming class, especially for graduate students, because they're always anxious about everything. They want to succeed so much. And then you did an anxiety test on them, the very first semester. And then in the second semester, you repeated it. And then in the third semester, so they have the fall semester, they have the winter semester, they have a summer semester, and then another. So you do it 4 times, repeat it 4 times to see where their anxiety level is over the 4 semesters. And that might make it a really good study. And that's the next category that I was talking about, a pre-test, post-test. So what you're doing is you're comparing all of those segments, first semester, second semester, third semester, fourth semester, to each other to see what changes has happened. Okay? I also have some grad students, and I think someone came up to me in this class talking about COVID testing and looking at depression and anxiety during COVID. Well, what you have to do, and what is a little difficult, is we didn't know what those things were before, so we have no actual number to compare it to now. So like the grad class, it would have been good to be taking measures of anxiety and depression all through COVID. And you might see some normative data. Normative data is a type of data that establishes a norm. So we may know that, levels of anxiety and depression or whatever have occurred all through the United States over the COVID experience, but that's the norm. So we're seeing more of it, but that doesn't tell you much about what's happening in Tiffin, Ohio, or what's happening in Ohio compared to a different state. So that's the drawback, and that's one of the things that pre-tests and post-tests are good for, to give you a baseline of comparison before and then after. But the problem with all of these things is that you don't always know when something is going to occur. So last year when I left for South Africa, we heard that there was a virus in China, and in your mind you're thinking, okay, it's like, bird flu or, SARS or something like that. And, it's minimized in your mind, right? Until it becomes a pandemic. Then it's like, oh my God, it's a pandemic. So you don't know that it's going to be what it's going to be at the time. So the research just wasn't there pre-pandemic, okay? So pre-test, post-test provides a benchmark, okay? So you can do research like that. I know I also am having, one of my grad students online is doing enrollments at universities pre-COVID and past and post-COVID. So that's good because places like universities and admissions offices kept track of those things. So for some of the things you can look at, the way it was before and after. But some things you can't, okay? The other thing is that during something, you can look at the changes during. So if you look at anxiety and depression, and you want to say, the next term we're talking about is correlation. So our anxiety and depression correlated with COVID, okay? So in that case, you would have your pre-test. So here's what we know pre-COVID, the norms for anxiety and depression in the United States. And you want to take measures as it goes along. So I've been keeping track of new cases since it started. So, because I'm working with my different research partners and we've been monitoring this. So I just published a thing yesterday, as a matter of fact, about the progress, the progression, the trend of new cases. And right now it's down, okay? So right now we're seeing a decline in new cases for COVID, which is cool. But I put a comparison of the high points. So we have a comparison. Thanksgiving was high, and after Thanksgiving, Christmas, and then New Year's was the highest, okay? So when those peaks of infection rates became high, did that also correspond to a peak in anxiety and depression? Okay, so that's a correlation. You can't necessarily say by just doing a correlation statistic that high case diagnoses is causing anxiety and depression, because there could be, here's another term, rival causative factors that are coming in and driving that data. So let's say you're looking at anxiety and depression and you're looking at the increase in infection rates, okay? But a rival causal factor that may make someone anxious or depressed is that maybe they lost their job because there's going to be a shutdown now because infection rates are so high. See, that's a rival causative factor because it's not necessarily the infection rates, it's the thing that happened because of the infection rates, like, we're going to shut down, businesses are going to close, people are having economic hardships, and so maybe someone's depressed because, okay, it went high, the infection rate went high, my place of employment closed down, and now I have economic hardship. So it's a bunch of rival causative things, not necessarily the one thing that you're looking at, okay? So again, correlation does not mean causation, and it could be a result of something else. A concomitant measure means an increase in one matches an increase in the other. So if you have an increase of infection rates and then an equal level of increase for anxiety and depression happen, we would say that that's concomitant. They're running together. That still doesn't mean it's causative, because you have to find out the thing that causes it, okay? It just means that they're rising and falling together, okay? So that's really interesting, okay? Now, are there times when research is not concomitant? Yes, and most frequently pharmaceuticals, okay? So if you take a drug, okay, you have an illness and you go to the doctor and the doctor gives you this medication and you feel this level of temperature or something, and then you take the drug and it brings down your level of temperature to a predictable degree. So drug use, oftentimes that's what we're shooting for, is a one-on-one relationship, right? So I often ask students, how many ibuprofen do you take if you take ibuprofen before you start to feel better? Is it, I've got a slight headache, so I'm going to take one. I got a little stronger headache, so I'm going to take two. I got a really strong headache, so I'm going to take three. I've got the worst headache ever, so I'm going to take 4. And do you expect that the number of ibuprofens that you take corresponds to the type of headache that you have? Okay, now some people will have like they'll have just a slight headache and they're like, oh my God, I've got a headache, I have to take all 4 of them. Take 4 right away because, you know, it's only going to progress. And, you know, there are people like that do that sort of thing. But that doesn't mean that their belief has any effect on the drug that they're taking. Okay, yes, it'll go away, but maybe it could have gone away with 1 versus 4. Okay, but some drugs are not additive or concomitant. Sometimes 1 plus 1 of a drug doesn't equal 2; it equals 4. Okay, so the drug in that case we would say potentiates. 1 plus 1 equals 2, but if you have a really potent drug, or the potency is different than 1 of that drug, it can create an effect that is much greater than 1 plus 1, and that's where overdose happens and things like that. So when you're doing a drug study, if you're in pharmaceutical industry, they really look at the potentiation of different types of drugs. So that's not a concomitant effect. That would be a potentiating effect. In other words, 1 plus 1 equals 4, not 1 plus 1 equals 2. So you have to worry about that. So drug companies do worry about that. And for every drug, they have an effective dose, or what we call an ED. That's what's on the bottle. It says dosage right on it. And then they also chart the death rate. Okay, so they look at, the whole thing is called a therapeutic index, how therapeutic is a particular drug. And then a lethal dose, or the LD, is where you take a drug that potentiates and could kill you. So there's if you go to the doctor and you get in the pharmacy, and they'll hand out a sheet for you, and it says do not exceed this dose in this amount of time. That's really just speaking to the LD, the lethal dose. Okay, so that's how concomitant correlation works. Okay, so the pharmaceutical industry will actually do experiments on animals, and they will figure out how much is too much. Okay, we often play with lethal dose without even thinking about it, because if you take if you're at a bar and you drink have a drink, and then you drink an energy drink, that is a potentiation, because alcohol is a depressant, so you're pulling your body down, and an energy drink is a stimulant, so you're putting like 2 opposite things into your body, and that would lead to a little thing we call stroke. So you should never do that. That is my scientific explanation for potentiating or non-concomitant effects. You know, sometimes 1 plus 1 doesn't equal 2. Sometimes 1 plus 1, if it's a potentiating drug, equals 4 or more. Okay, beyond the therapeutic index and the lethal dose. So never take a depressant and a stimulant together. Like, I know it's a popular drink when you can have you know, an energy drink and an alcohol, but that's just really just playing with fire. So that's what it's called. It's called not a concomitant variable. It's called a potentiating variable. Another way that we plot that out, and we go to plot it out on a graph, is called a monotonic relationship. And a monotonic relationship just means it's like a chart that you can see actually one of this and one of this down here equals a straight line. That's called a monotonic relation, a 1-for-1 relationship. Okay, so that just happens. You know, we might look at your data and we might find a 1-on-1 relationship. You know, we'll have to look at that when we get into statistics. But I just wanted to give you an overview of what that might be before we get into that in the lecture. Okay, so I'm going to stop this here for now, and then we'll go on to part 2, and I'm going to put a lecture guide 2 for you as well. Okay, hang on for part 2.